25. I'll go ahead and get started. Okay, before spring break, the last thing that we covered ended a chapter. So we're starting in chapter 6 now, which is called, we're going to do all different kinds of what's called factoring. Okay, each section is kind of covering a different type of factoring. When you are doing factoring, what you're doing is you're going to be given a group of terms and you're kind of finding out what was multiplied together to get those terms. What do you mean?
I thought you figured out how to get onto that.
Oh, no.
I have some students
No, I don't know how. I don't even know how to turn it on. I don't even know how to turn it on. So we're going to find the things that are multiplied together to give us that group of terms. For instance, when we had, it's kind of going backwards from this. Okay, in the last section, we would have had something that looked like this, and we would have been asked to distribute or multiply these two things together. If we multiply this, x times x would give me x squared. X times positive 7 would give me positive 7x. What we're going to be doing in this section is we're going to be given this and asked to take it back to the factor before it was multiplied together. Okay? The first thing that we're going to cover here is going to be called the greatest common factor. Okay, so that's going to be our first type of factoring. Okay, so looking at number 1 on your homework sheet, you have x squared minus 9x. And it's going to say, write in factored form by factoring out the greatest common factor. So what you're going to be doing is looking at, in this case, the two different terms. And we're going to try and find the greatest thing that they have in common. And we're going to pull it out. So let's see. This one, you can look at both of these terms and see that they both have x's. If your terms all have x's, you want to pull out as much as you can from both of them. So what you're actually going to do is look at the two terms, look at their x's. Whatever the smallest amount of x the terms have is, that's what they have in common. So this one has x squared, and this one just has x, which means x is going to be the greatest common factor, right? This doesn't have any more than just x. Now, when I'm looking at the number part of the terms, I see this one has a 1, and that one has a minus 9. So you could pull out a 1, but it's usually going to say that that doesn't do anything for you. So this is all that is in common with these two terms. So after you pull it out, you are going to put in parentheses what's left. So how do I find what is left? Whatever you pulled out right here, you're going to divide both of those terms by that. So let's see here, if I had x squared and I pulled out an x from there, I'm going to just be left with an x, right? Because essentially you're subtracting those exponents. So the 2 minus the 1 just gave you x. Bring down the minus. If I pull the x out of this term, all that I'm going to be left with is that 9. And you're done. So they had x in common. I pulled it out. Then I said I need to put in parentheses what is left. So to find out what is left, you divide by whatever it was that you pulled out. Because if you can't divide by it, that means it wasn't in common. Okay, so this is your answer that you put in. That's the answer to the problem. So just to show that, to check it, you could say, okay, I'm going to distribute this x back through, and it should take me back to my original problem. X times x gives me x squared minus x times 9 is 9x. Okay, so that's how you go back and forth between the two. This is the factoring part. And then if you wanted to check it, you would just distribute it back through. All right, let's look at number 2. Six t squared plus 3t. So looking at these two terms, this time, can these two numbers divide by something in common? Do they have anything in common? What does 6 divide by? It divides by 6, 3, and 2, right? All those numbers go into 6 evenly. What can this one divide by? Well, it divides by 3. Don't they both divide by 3 evenly? And they do, which means you can pull out a 3. They have a 3 factor in common. Looking at the two terms. Now, I see that they both have some t. So I'll just look at my exponents. Whatever the smallest one is, that's the most that I can pull out of both of them. This one has t squared. That one just has t. So I can only pull out a t. Put in parentheses what's left. How do I find out what's left? And I always like to write it just because I can visually see it, especially on something like this. So if I'm dividing by what I pulled out, whatever you pulled out here is what you divide by. So let's see, 6 divided by 3 gives me 2. I had t squared, but I pulled out a t, which means I just have a t left. Bring down my plus. Now here's a good reason to write that 3t under there. I pulled a 3t out, but I only had a 3t. But when I look at it like this, what is that number that is left? Anything over itself. If you divide something by itself, you are left with 1. Again, if you wanted to check it, you could distribute this back through, right? 3t times 2t would give you that 6t squared, plus 3t times 1 gives you that 3t. All right, I'm actually going to do a few more that aren't on the paper or aren't on your assignment right now because number 3 kind of jumps into something even more complicated. So I want to look at a couple of other ones before we go into that. Okay, this time I've got 3 terms. And I'm looking for what's in common with all 3 of them. So let's just take each thing separately. The number part and then the x part. So my numbers are 3, 9, and 15. I'm trying to find a number that they will all divide by evenly. Okay, I would look at this one first because the only thing that 3 is going to divide by evenly is 3, right? No other numbers go into 3 evenly besides 3. Will 9 divide by 3? It will. And will 15 divide by 3? It will. So I could definitely pull out a 3. Do they all have x's? They do all have x's. So let's see how much x I can pull out. This one has x to the third. This one has x squared, but this one only has an x, just an x, no more than just an x, which means I can only pull out an x, right? Because if I pulled out more than x, like x squared, I would be in trouble here. This one doesn't have enough to pull out x squared. These both do. But the only thing I can take out of all 3 terms is an x. So 3x is what's in common. Let's see what's left. Again, I like to write it under everybody so I can just visually see what I'm dividing by. I pulled out the 3. I pulled out I had x to the third, and I pulled out just one of those x's, just an x. So if I subtract those exponents, I see that I still have x squared left there. Plus 9 divided by 3 gives me 3. I had an x squared, but I pulled out an x, which means I still have an x. Plus 15 divided by 3 gives me 5, and I pulled out that x. Okay, I'm going to do one more before we jump into number 3 on your homework. Okay, got 2 terms here. I want to pull out, remember, it's the greatest common factor, not just any common factor. Let's look at our number parts first. I've got 6 here and 18 here. I can see 2 goes into both of them. So does 3, right? They both divide evenly by 3. But so does 6. Don't they both evenly divide by 6? So remember, you are pulling out the very highest thing that goes into both of them. So pulling out a 2 or a 3, even though they will both divide, is not pulling out the greatest factor that they have in common. Okay, so the biggest number that goes into both of those is a 6. Now, look at your x's this time. Here I've got x to the 5th. Here I've got x to the 4th. So they actually have more in common than just an x this time. I can actually pull out x, whatever the smallest exponent is. So I can actually pull out x to the 4th. So let's see what's left. After I pull out 6x to the 4th, again, I like to right underneath what I'm dividing by. Look here, I pulled out the 6. I had x to the 5th, but I pulled out x to the 4th. So if you subtract those exponents, you're just going to be left with an x minus 18 divided by 6 gives me 3. Here I had x to the 4th, but I pulled it out. So there's not any x's left there. So you just close your parentheses. So again, again, the important things that I wanted to point out on this one is that 6 and 18 had several numbers that they divided evenly by, which means I have to use the highest. Let me show you what would happen if you didn't pull out the highest. Let's just say, this is the answer. We're done with it. I just want to show you how you would catch yourself. So let's say I started working this problem and I said, oh, those are both even, which means 2 goes into both of those. So I'm going to pull out a 2, and the smallest exponent would be x to the 4th. Here's how you would catch yourself. Oops. If I divided this, 6 divided by 2 gives me 3. I had x to the 5th, but I pulled out x to the 4th, so I still have an x. Minus 18 divided by 2 gives me 9. I pulled out all the x. Look at what's in your parentheses. If you pull out the greatest common factor, there should be nothing in common with what's in your parentheses. What goes into 3 and 9? 3 does, which means they still have something left in common in them, which just means what you pulled out at the beginning was not the greatest common factor. If you pulled out the greatest, these 2 numbers won't have anything in common. Since they do, that means that's what kind of tells you that 2 wasn't the biggest thing you could have pulled out. There was something bigger, okay, which was the 6. All right, now let's go to number 3 on the homework. Negative 48, x to the 4th minus 8x to the 3rd. Looking at these 2 terms, first of all, you do want your terms in a certain order. You do want your term with the highest exponent to be first, which it is. If that term is negative, you're going to pull the negative out along with whatever else is in common. So again, looking at your 2 terms, if this leading term has a negative, you want to pull it out. So I'm going to pull out a negative along with whatever else is in common. So let's look at my numbers, 48 and 8. A lot of times what I do, if I'm not sure, like I can tell these probably have more than one thing in common. I'll always go to my smallest one and find its factors, which means all the ways to multiply to get it, which would be 8 times 1, and how else do you get 8? 4 times 2. So all of those numbers are all of 8's factors. Those are the only ways to multiply to get 8. So then I want to find the biggest one that also is a factor of 48. Or in other words, what's the biggest number out of this group that 48 will also divide evenly by? So I'm going to check the biggest number first. Does 48 divide evenly by 8? If you're not sure, just use your calculator and see. 48 divided by 8. If that's not a decimal, that means it does divide evenly by 8. So which means 8 goes into 8 and 48. So I'm going to pull it out. That's its greatest number factor. Now the exponent part, now that we've learned kind of the shortcut, is the easy part. You're just looking at your x's. Whatever the smallest exponent is, that's what you're pulling out. So here's my greatest common factor. here. I'm going to put in parentheses what is left. Again, especially when you start getting to ones like this, it's very important that you just put whatever your greatest common factor is, negative 8x to the third, underneath there to divide it so you can see that. So let's see, especially when you have a negative, because now I can see I have negative 48 divided by negative 8, which is positive 6. I had x to the fourth, and I pulled out x to the third, which means I still have an x. Here again, I've got a negative divided by a negative. So what does that do to that sign? It changes it to a positive. And I have the same thing on top and bottom. So what is that when you divide something by exactly itself? 1. Close your parentheses. All right, let's look at number 4. $11w to the third minus 100. So again, looking at the two numbers, I'm going to find the factors of 11 because 100 has a lot of ways to multiply to get it. But 11, that's the only way to multiply to get 11. 1 doesn't help me, right? If I pull out a 1, let me show you this. Don't write this down. If you pull out a 1, because 1 goes into everybody, right? But if you divide those by 1, what are you going to have left? Well, something over 1. 100 over 1, you still have that. You didn't do anything, right? So that's why a 1 even though it goes into everybody, it doesn't help you when you're pulling out the greatest common factor because you'd still be left with exactly what you started with. Okay, so nothing is in common with 11 and 100 other than 1. This one has w to the third. This one doesn't have any w, which means they don't have any w in common either, which means this one, if you're looking at your options, you would check this B option, right? There is no common factor other than that 1, right? 1's in common with everybody. But it doesn't help you in this kind of case. So this one, it's a lot of times you hear people call it prime. Okay? There is just no common factor other than 1. Okay, let's look at number 5. (8m(n) to the 5th plus 152m squared n to the 5th. So we're just going to take this one thing at a time. First things first, don't even worry about the m's and n's yet. We just got an 8 and a 152. I don't want to think about all the ways to multiply to get 152 when I can do this with the 8. Right? How do you multiply to get 8? 8 times 1 and 4 times 2. I don't even care about the 1 because it doesn't help me. So what do I want to check? I need to find the biggest number between these that 152 also divides evenly by. So the first thing I'm going to try is the 8, because if it divides evenly by 8, then I'm done. I have no idea if 152 divides by 8, so I'm just going to ask my calculator. If that's not a decimal, then 152 does divide evenly by 8. So since it is not a decimal, that means 8 goes into what 8? And 152. So I'm going to pull out an 8. Now just do each letter separately. So let's see here. This one just has M. This one has M squared. So between those M's, who has the smallest exponent? Well, the M does. So I can't pull out, I can just pull out an M. Looking at your N's. This one has N to the 5th. This one has N to the 5th. So they actually have the same exponent, which means they have N to the 5th. Don't they both have it? So they have N to the 5th in common. And that's it. Putting in parentheses what is left. So again, I am going to, whatever I pulled out, that's what I'm going to divide by. So let's look at this first one. Let's see, what is left? Do I have anything left, or is the top the same exact thing as the bottom? If I'm dividing 8M into the 5th by 8M into the 5th, you are left with 1, right? If you divide something by itself, it's equal to 1. Plus 152 divided by 8. I just did that in my calculator. It told me 19. Do your M's. Here I had M squared. I pulled out one of those, right? If I pulled out, I had M squared, I pulled out M. I'm still left with an M. I had N to the 5th, but I pulled all of that out. So I don't have any N's left. Right, number 6. Ooh. 40 P to the 5th Q plus 15 P to the 4th Q to the 5th plus 25 P squared Q squared. All right, now this one seems daunting, but remember, we're just going to take it one thing at a time. We're going to do the numbers, see what's in common with the numbers. Then we're going to see what's in common with P, and then we're going to see what's in common with Q. If you just take it one separate thing at a time, it becomes not as overwhelming. So let's look at my numbers. Here I've got 40, 15, and 25. Okay, a lot of times I'll just go to that smallest one and write out the ways to multiply to get it. Write out its factors. So let's see, 15 would be, the ways to get it would be 15 times 1 and 5 times 3, and I'm not going to worry about the 1. So the first thing I'm going to check is the 15, right? Because you're trying to find the biggest thing that goes into all of these. But what happens when you divide? Let's check the 40 and see if it divides by 15. If I did 40 divided by 15, it gives me a decimal, which means I can't divide 40 by 15, so I can't use that. So then my next biggest number would be the 5. If a number ends in a 0 or a 5, that means it divides by 5, right? 40 divides evenly by 5, 15 does, and so does 25. So the biggest number factor that they have in common is that 5. Let's now move on to the p's. Remember, you're going to go to each p and look at its exponent, and you're going to be able to pull out whatever the smallest exponent is. So I've got p to the 5th here, p to the 4th here, and p to the 2nd here. So the smallest exponent is this p to the 2nd. So that's what I'll pull out. And do the same thing with your q's. Q to the 1st, q to the 5th, and q squared. So the smallest exponent is just that q. So I'm going to pull out a 5p squared q. Put in parentheses what's left. I'm definitely writing this underneath each one so I can see it and not miss something. So 5p squared q, 5p squared q, and 5p squared q. So divide them all by that. And let's see, let's divide them. 40 divided by 5 gives me 8. I had p to the 5th. I pulled out p to the 2nd. So if I subtract those exponents, I'm going to be left with p to the 3rd. I had a q, but I pulled it out. So there's no q left. So I'm done with that one. Bring down my plus. 15 divided by 5 gives me 3. I had p to the 4th. But I pulled out p squared, so if I subtract those exponents, I'm left with p squared. I had q to the 5th, but I pulled out one of those q's, right? I pulled it out. If I'm dividing by it, I'm pulling it out. So if I had q to the 5th, but pulled out one, I'm left with q to the 4th. Done with that one. Bring down my plus. 25 divided by 5 gives me 5. I had p squared, but I pulled out p squared. So no p's left. Here I had q squared, but I only pulled out q. So I still have one q left in that last term. And then that's it. Okay? I'm going to put another one on the board and let y'all work it. I'm going to put one like this, because if you can work one like this, then you're good to go on greatest common factor, because starting in number 7 is a different type of factoring. Okay, I'm going to pause the video and give y'all a few seconds. Okay, so we've got 36, 18, not going to worry about that sign yet, and 45. So I'm going to write out all the ways to multiply to get 18, just since that's the smaller one. So let's see. 18 times 1, also 9 times 2, and also 6 times 3. So let's see. I'm not going to use a 1. Let's see if 18 goes into all of them. So first thing I'm going to do is see, I know 18 is going to go into 18, right? Everybody goes into themselves. Okay? But let's see if 36 divides by 18. So 36 divided by 18, it does. So there's no decimal. So I'm almost there. I know it goes into 18, but what about 45? Remember, I'm going to have to divide all three of those things by whatever I pull out. So when I divide 45 and I divide it by 18, it gives me a decimal, which means I can't use 18. Okay, because if I got to this part right here and tried to divide that by 18, then I would run into a stumbling block, right? It would give me a decimal. So can't use 18. So my next biggest number is 9. Let's try 9. Let's see. 36 divided by, divided by 9. So that's good. I don't have to check the 18, right? All the numbers go into 18. That's what this whole thing was for. Let's try the 45. It also gives me a whole number and not a decimal. So this right here means 9 is the biggest number that goes into all of them. So I'm going to pull out a 9. Let's see, my x's, looking for the smallest exponent, x to the 5th, x to the 2nd, and x to the 3rd. So that x to the 2nd was the smallest exponent. So I'll pull it out. My y's, I've got y to the 4th, y to the 3rd, and y to the 5th. So if I'm looking at my exponents, this y to the 3rd is the smallest one. So that's what I'm going to pull out and put in parentheses what is left. Which means divide everybody by this right here, what you pulled out. So 9x squared y to the 3rd. So here, 36 divided by 9 gives me 4. My x's, I had x to the 5th. I pulled out x squared. So if I subtract those exponents, I'll have x to the 3rd left. Onto your y's. I had y to the 4th. I pulled out y to the 3rd, which means I just have one y left. So I'm done with that one. Moving on, plus 18 divided by 9 gives me 2. I had x squared, but I pulled out x squared. So how many x's left? Y to the 3rd, but I pulled out y to the 3rd, so I don't have any y's left. So when I do this, all my x's and y's canceled, so I'm just left with that 2. Minus 45 divided by 9 gives me 5. I had x to the 3rd, but I pulled out x squared, so I still have x. My y's, I had y to the 5th, but I pulled out y to the 3rd, which means if I subtract those exponents, I still have y squared left. Okay? All right, now the last 4 problems are going to be a little different. Actually, a lot different. Factor 4 terms by grouping. So looking at number 7, 6m plus mn plus 18 plus 3n. So how do I know that I'm doing something different than I have been doing? Okay, first thing you always look for is a greatest common factor. Something in common, what we've been doing the whole time. But when I look at my numbers, I've got 6, 1, 18, and 3. This one, I can't pull out anything because the only thing this one has is a 1. And remember, pulling out a 1 does not help me. I still have the same exact thing. So there's not any numbers in common other than the 1. This one has an M. This one has an M. But these don't. So I can't pull out any M's. They don't have any M's. Not all of them have it. And then those two terms have N's, but these don't. So I can't pull out any N's either. So other than the 1, there's nothing in common with all 4 terms. That's the other clue, that there are 1, 2, 3, 4 terms, and there is nothing in common. That's what's telling us that we're going to factor by what's called grouping. So the first step, the whole reason it's called grouping, is you're going to put the first 2 terms in a group, and then you're going to put the second 2 terms in a group. Now, here's the reason it's actually in the greatest common factor section. This is still 6.1, still the same section. It's because looking at these 2 terms now, you're just going to look at the smaller groups and pull out what's in common in them. So just looking at this first group, no numbers in common other than 1. They do both have an M. So I can pull out an M, but that's it, right? They don't both have N's, just this one does. So what these 2 terms have in common is just that M. So just like we've been doing the whole time, pull out what's in common, put in parentheses what is left. Just like always, I'm going to divide what I put in there by what I pulled out. So let's see here what's left. I pulled out the M, so all I'm left with is that 6. Bring down my plus. I pulled out the M, so all that's left here is that N, and that's it for that part. Looking at my second group, I'm going to do the same thing. I'm going to pull out the greatest thing they have in common. This is an 18. That is a 3. They don't have any letter in common, so hopefully they've got some number in common, right? So dealing with the 3, since it's the smallest, how do you multiply to get 3? There's only one way. So the biggest thing that goes into 3 is 3. Does 3 also go into 18? It does, evenly. 18 does divide evenly by 3. And what kind? I'm going to pull out a positive 3. Put in parentheses what is left. Same thing. Divide those by what I pulled out. 18 divided by 3 gives me 6. Plus, if I pulled the 3 out of this term, all that's left is the N. Now, this is how factoring by grouping problems are set up. Once you pull the common factors out of each of the smaller groups, what's in your parentheses are going to be the same. Now, if you're separating these by this plus sign, this side and this side, they've got this whole group in common, which means I can actually pull out that whole 6 plus N. They both have it. So if I pull out the entire 6 plus N, what is left. So let's see, what do I do with what I pull out? I divide both of the things I pulled it out from by it. So if I divide these both by that 6 plus n, just hang with me. We're going to do several of these. I know this is weird. What happens here? If I pulled out the 6 plus n, what's left here? Just that m. If I pulled out the 6 plus n from here, what's left on the back half? Just the plus 3. And then you're done. Now, kind of a shortcut that you can do on this is once you get to this part, instead of pulling the 6 plus n out of both of those, the shortcut kind of thing is I'm going to end up with two factors, two things in parentheses after this. One of the parentheses is going to be what's in common here, so 6 plus n. The other parenthesis is just going to be those terms, what's on the outside, which is m plus 3. Okay, let's do another one. Number 8. Factor by grouping. I've got 4st plus 10t minus 10s minus 25. So 4 terms. If I looked for something in common all the way across, I wouldn't be able to find anything in common. You'd come close, but nothing would be in common with all 4, which means I'm going to put the first 2 in a group and the second 2 in a group. And then it's almost like looking at 2 smaller greatest common factor problems. Just worried about this first group, what they have in common. So let's see, my numbers are 4 and 10. So I'm going to write out the factors of 4, since this is the smallest. So let's see, 4 is the biggest factor. It goes into 4. But does 10 divide evenly by 4? If you divide 10 by 4 in your calculator, you're going to get a decimal, so it's not 4. What about 2, though? Will 2 go into 4? Yeah, all the numbers here go into 4. Will 2 also go into 10? It also goes into 10, so I can pull out a 2. This one has an S, but this one doesn't, so I can't pull out any S, right? They both have to have it in order to pull it out. This one has a T, and this one has a T, so they do have a T in common. So here's what's in common. Put in parentheses what's left, which means divide them both by what you just pulled out to see what's left. So let's see, 4 divided by 2 gives me 2. I had an S and I didn't take out any S, so I still have an S. But I did pull out that T. Plus 10 divided by 2 gives me 5. And I did pull out the T, so I don't have any T left. So 2S plus 5 is what's left in this parenthesis. So let's look at this other one. Don't worry about your negative just yet. We are going to definitely worry about it, but not when I'm trying to find out what's in common. I've got 10 and 25. 10's my smaller number. So I need to find the biggest factor of 10 that will also go into 25. So the biggest factor of 10 is 10. But will 10 go into 25? it won't. The next biggest factor is 5. So all these numbers go into 10, so I don't even need to check it. Does 5 also go into 25? It does. So 5 is going to be what's in common. And this one has an S, but this one doesn't. Here's where you're going to have to worry about the sign. Remember, what you have left in this parentheses has to be the same thing you had left in this parentheses. So check what's going to happen if I just divide those by 5. What is negative 10 divided by 5? It's negative 2s. What do I want it to be though? Positive 2s. So what does that mean I need to pull out along with this 5? What's going to turn this into a positive 2? If I divide it by negative 5, right? That's what's going to turn it into a positive 2s so that it'll be the same as this one. So I'm actually pulling out the negative along with that 5 so that I can change this to a positive 2, like I want it to be to match this one. So negative 10 divided by negative 5 is positive 2. I still have the s. So I pulled out negative 5, right? What's negative 25 divided by negative 5 gives me positive 5, right? Because a negative divided by a negative is a positive, like I want it to be. So these match, which means I did the right thing. You're going to have 2. Once you do this, you can kind of take that shortcut and say, okay, I'm going to have 2 parenthesis factors. What's in common is going to be one of them. So 2s plus 5. The other parenthesis comes from where? This and that. So what's the other parenthesis going to be? 2t minus 5. And you're done. All right, we got 2 more. Number 9, 9z squared plus 27z minus az minus 3a. So 4 terms, there's nothing in common with all of them. It kind of looks like there's going to be, but if you started looking, there's not anything that all 4 terms have in common. That's why we put them in smaller groups. Looking at my first group, I have 9 and 27. So use the smaller number and let's see how you multiply to get 9. 9 times 1. 3 times 3. Okay, so somebody's not muted.
Here. So you know the first word is what? What's the first word?
So this right here, if I'm looking at these 2 terms to see which ones 9 goes into, I know it goes into 9. Well, does it also go into 27? Yeah, 9 also goes into 27. So 9 is what I'm going to use. This one has z squared. This one has z. The smaller, they both have z, so how much can I pull out? Whatever the smallest exponent is, so I can pull out a z. Put in parentheses what's left. So let's see what's left after I pulled out a 9z. So here I pulled out the 9. I had z squared, but I pulled out a z. So I still have a z left. Plus 27 divided by 9 gives me 3. I had a z, but I pulled it out. So I don't have any z's left. So z plus 3 is what is left. Now, 9 times out of 10, and actually 10 times out of 10 on all the ones that you're going to have, if this first term of the second group is negative, you're going to have to pull it out to change the signs. Because what do these two terms have in common? They have the A in common, but if I just pull out A, so if I just took out this A, what am I going to be left with? I still have the negative Z. I need Z to be positive. So that's what's telling me I actually need to pull out the negative and the A so that I'm just left with the Z like I want. So I'm pulling out negative A. So again, 9 times out of 10, if you're looking at your second group and that first term has a negative on it, you're going to have to pull it out to change the signs. So let's see, if I pulled out the negative A from this first term, all I'm left with is Z. And here I have a negative on top and bottom, which is going to turn that positive, right? Because a negative over a negative makes it positive. And what did I pull out? That A. So all I'm left with is the 3. So there's my groups. Remember, these have to be the same. One of your answers, one of your factors of your answer is what's in common there. So the Z plus 3. And what's the other one that goes in this parenthesis? What you pulled out here, which is 9Z, and what you pulled out there, which is minus A. Okay, I'm going to put number 10 on the board and let y'all work it. I'll pause and let y'all work it. This is the last one, and if you can do this one, you can do any of them. Nine m to the third minus 3m squared p squared minus 3m p plus p to the third. So do that one by grouping. This one. So nothing's in common with all 4. That's why you group them. So looking at my first group, look at just the number part first, right? So I've got a 9 and a 3. So I'll use the 3 to find my factors. So 3 is the biggest factor, so I know it goes into 3. Does 3 also go into 9 evenly? And it does. So I'm going to pull out a 3. The next thing I'm going to look at is my m's. This one has m to the third. This one has m to the second. So remember, when you're looking at the variables, the letters, you can pull out as much as the smallest exponent. So if I have m to the third and m squared, I can pull out as much as m squared. This one has a p squared. This one didn't have any p to pull out. So I can't pull out any p. There's no p in this first term. So that's all I can pull out. So we're going to open our parentheses now. And we're going to put in there what is left. So let's see if I'm going to divide these both by what I pulled out, which is the 3m squared. Let's look what's left. 9 divided by 3. So that'll give me the 3. I have m to the third, but I pulled out m squared. So if you subtract those exponents, or if you think of it as having m to the third, but you pulled out 2 of them, you've still got an m left. So I've got 3m left in this first term. minus, I pulled out that 3. I had m squared, but I pulled out m squared. So I don't have any m's left. So all I'm left with in this second term is that p squared. Now, looking at your second group, is my first term in this second group negative? That means that probably I'm going to need to change signs. So let's pull out the negative along with, and a way you can check it is if this term is negative, but the first term in this parentheses is not, that means you're going to need to change the signs. So I'm going to pull out the negative along with whatever else is in common. There's no number other than 1 in common. This one has an M, but this one doesn't. So I can't pull out any M. They do both have some P though. So here's where I'm going to pull out whatever the smallest exponent is. So if this one has P and this one has P to the third, I can pull out a P, right? They both have P in common. So here's what I pulled out, negative P. So that's what you put underneath here. And divide by that. So let's see, I pulled out the negative. A negative over a negative is just going to turn that positive, right? So what's the only other thing I pulled out? I pulled out this P. So this is going to be left with just positive 3m, right? Pulling out the negative, turned it positive. I pulled out the P. So essentially those things are gone. So all I'm left with is that 3m, which is what I want, right? It needs to match this. This one, positive over a negative, turns that negative. I had P to the third, but I pulled out one of them. So I still have P squared. Then the last part, remember, you're going to have 2 factors in parentheses as your answer. One of them will be, this better be matching. If not, something's wrong. So one of the factors is that matching 3m minus P squared. The other one comes from those. So this first, 3m squared, and then minus P. Okay? So 6.1 should be open. On Thursday, we are going to cover 6.2 and 6.3. It's going to be a lot. I highly recommend you come live for that lecture. I'm going to show you lots of shortcuts, lots of calculator tricks to make those sections so much easier for you. Okay, so you definitely want to be live on Thursday. Okay, I'm going to stop the video, but I am going to stay.